All right, you have already started using this idea of something called like terms. These are terms that essentially have the same exponent or the same variable with the exact same exponent. And we're going to continue that idea and then use it while adding and subtracting polynomials. So if I look at 12x as one term, if I can find other terms that exactly match it, I would need other terms that have just an x with them. So this negative x also is a like term with 12x, as well as negative 4x is all like terms. These all have x's in them, and no exponent, it is just an x attached to it. But then if I look at my next term right here, 6x squared, that's one term, but if I can find that matching like term, I'd have to look and find the x squareds, which is 3x squared is the other like term. And so these can be added together because they both have an x squared attached to them. And then the last type of term that I have is the number 18. 18 is a constant, a number without a variable. And so that can go in my last box. And the 18 has a like term, this number 5. Both of them are constants. They're just plain old numbers. So those are my different categories, and I'm going to use that idea as I begin adding and subtracting polynomials. So this very first problem is 5x squared plus 8x minus 3 plus 2x squared minus 7x plus 13. And we're going to look and kind of find our like terms and line them up. So if I write that first polynomial in standard form first on my first line, I then can line up each term separately. So the 2x squared is going to go in my first column. The 7x is going to line up with my 8x in the second column. And the 13 is my constant. It's going to line up with my 3 in my third column. And then I have just these simple addition problem in which I'm using my columns to add all of my integers up. So if I have negative 3 plus 13, that gives me a positive 10. I have 8 plus negative 7. If I add those together, I get a positive 1x. I can write that 1 there, but I also don't necessarily need it. And then I have this 5x squared plus 2x squared, and 5 plus 2 gives me 7x squared. Notice that my exponent did not change. It stayed the same because I'm combining together the like terms. So all that changes is my integer, my coefficient that's in front of it. So my final answer is 7x squared plus x plus 10. If I look at this next problem, I can also order it because I also have like terms. So I'm going to go ahead and have 15x squared minus 12. And I'm going to add that to my 8x squared is going to go in the first column. And notice there's nothing that really combines with 10x. It's a little bit by itself. So 10x I'm going to make sure and put in its own column. So plus 10x. And then my constant, that negative 4, that's going to go in my constant column. So again, I have this lined up perfectly. However, I'm going to have kind of a missing space in my x column. So let's go ahead and do some addition. When I add negative 12 plus negative 4, I'm going to get negative 16. And if I have nothing plus positive 10x, I'm going to get a positive 10x. And then in my last column, 15x squared plus 8x, that gives me 23x squared. And that is my final answer. The next section, we're going to talk a little bit about subtraction. It's a little bit different. If we remember, just as an example, if we remember some just integer operations, if I had something like 6 minus negative 2, we keep, and then you're going to change twice, change. So I'm going to keep my sign for my first number. If I subtract, I can flip it to a positive, and that changes my sign of the negative 2. So 6 minus negative 2 is actually to positive 8. So I'm going to go ahead and erase that part. But keep that in mind as we work on these problems, that situation where I have 6, if I have minus a negative, it becomes plus a positive, or if I have minus a positive, I'm actually taking it away, and I end up getting those different answers. Okay, so for number 14, what we're going to do is do the same thing that we did with our addition. We're going to line them up just like we did previously. And so let's go ahead and take that 6x to the third and rewrite it, plus 7x minus 4. And we're going to rewrite out that second polynomial, 3x to the third, in my exact columns. But this time, instead of adding, we are subtracting. And the step I'm going to use is that we're going to change the signs for everything in this second polynomial. So that means I'm going to change this to an addition problem and flip the sign on every number after it. So I have a negative 3 now. This minus 2 becomes a plus 2. And this plus 6 becomes a negative 6. So I have changed this addition sign, I changed the subtraction to an addition problem, and flipped every sign. So now let's go ahead and solve it. So for that first column, I have negative 4 plus negative 6 gives me negative 10 now. A 7 plus 2, 7x plus 2x gives me plus 9x, a positive 9x. And a 6x to the third plus a negative 3x to the third is 3x to the third, 6 minus 3. So here is my final answer, 3x to the third plus 9x minus 10. Let's try one more. Again, let's go ahead and rewrite them. 5y to the third minus 8y to the second plus 15. And let's line up that second polynomial. Negative 3y to the third is in the first column, plus 2y to the second in my second column, plus 5. And again, I'm subtracting, so I'm going to do that same exact idea where I'm going to change my signs on my second polynomial. So this is going to become a addition problem, and that'll flip this to a positive 3. My plus 2 is now a negative 2, and my plus 5 is now a negative 5. So then if I were to look at this first column, 15 plus negative 5, or in other words, 15 minus 5, gives me a positive 10. And my next row, negative 8y squared plus negative 2y squared. If they're the same sign, they're going to stay the same, negative 10y squared. And my third column, the very front, 5y plus 3y to the third. That gives me a total of positive 8y to the third as my final answer. The last possible trick question is that when I have something in standard form or not in standard form, it needs to get written into standard form. Standard form is very important. So if we look at this very first polynomial, we'll notice that it is actually not in standard form. My highest exponent is not written first. Instead, my highest exponent for some reason is in the second spot in that polynomial. So I have to rewrite it. So let's go ahead and rewrite this first polynomial. Remember that minus sticks with the number that it's in front of. So I'm going to rewrite that first polynomial as negative 17x to the second power plus 3x is going to come next minus 9. That's my first polynomial. My second polynomial, I'm also going to rewrite in standard form. I have to make sure the columns line up, that the x's match. So I have negative 3x squared plus 5x is going to be in the second column plus 18 is in my third column. And we are adding these polynomials, so we're going to just add straight up and down each column. So negative 9 plus 18 gives me a positive 9. 3x plus 5x is a positive 8x. And in my third column, negative 17x plus negative 3x is negative 20x. Sorry, I'm saying x squared. Negative 17x squared plus negative 3x squared is negative 20x squared. So those are all of our examples for today. Try your best and do the activity for today. Remember that we always rewrite our polynomials in standard form. And second, we're going to line up our like terms. So that means that the x's go on top of the x's, the x squareds go on top of the x squared, so on and so forth. You have to make sure you have those like terms. And then lastly, when we're subtracting, you must change those signs of that second polynomial. So if you're doing 7x minus negative 10x, we have to change those signs so that we can get a 17x instead of an incorrect answer.